Assalamualaikum, my name is Amirahtul Jannah and my team members Anisah Nabilah and Shuhada Zainal. We want to present the video assignment CMT 585 Petroleum Technology. Our title is Comparison the Technology of Fixed Bed Combustion, Fluidized Bed Combustion, Coal Liquefaction and Coal Gasification, and assess their advantages and disadvantages in terms of producing clean coal energy. As we know, coal is a fossil fuel that is formed from the remains of plants that lived and died millions of years ago. Coal is widely used for the electricity generation, industrial process, and as a fuel sources for heating and cooking. There are four major types of coal, includes anthracite coal, bituminous coal, subbituminous coal, and lignite coal. Each type of coal has different characteristics and uses. Generally, as the range of coal increases from lignite to anthracite, which have a higher energy density and burn more efficiently. The combustion of coal is a complex process involving various chemical reactions. The carbon in the coal react with oxygen to form carbon dioxide, while the hydrogen present in the coal combines with oxygen to form water vapor. This combustion process releases a significant amount of heat energy. In addition to carbon dioxide and water vapor, the combustions of coal produce other byproducts and pollutants. For example, sulfur present in the coal can cause acid rain. On average, anthracite coal has a higher heat calorific value CV, ranging from 27 to 35 million BTU per ton. Due to solve this issue of pollutants, coalification was introduced. In both direct and indirect coalification, the process involved the removal of moisture, volatile compounds, and impurities, resulting in the concentration of carbon and the formation of solid, carbon-rich coal.
The process of combusting coal for the production of heat and energy is known as a coal combustion. Coal combustion involves directly burning coal to produce heat, which is then converted into an energy such as electricity or heat for the industrial processes. The heat produced by coal combustion is utilized to generate steam, which operate turbine attached to the generator. Because of this, it will transform the energy conserved in the coal into electrical power. It has become an essential part of the worldwide energy mix. While it is a widely used technology, coal combustion emits significant amounts of pollution, including carbon dioxide, CO2, sulfur dioxide, SO2, and also nitrogen oxide, NOx. And it also has particulate matter contributing to the air pollution and climate change.
Coal liquefaction and coal gasification offer potential alternatives that could mitigate some of the environmental impact associated with coal combustion. Additionally, by converting coal into liquid fuels, coal liquefaction provides an opportunity to utilize coal resources more efficiently and diversify the energy mix. This process also produces carbon dioxide emissions. This technology can capture and store a significant portion of this emission. It is an energy-intensive process and can be associated with higher greenhouse gas emission. While for coal gasification enables the extraction of valuable byproducts such as hydrogen, which can be utilized as cleaner energy sources or as feedstock for various industrial processes. However, coal gasification requires advanced infrastructure, and it is typically more complex and costly to implement compared to coal combustion. In addition, the incomplete combustion of hydrocarbon fuels can result in the release of harmful pollutants like carbon monoxide, which it is a toxic gas which contribute to air pollution. It is important to ensure that proper ventilation and sufficient oxygen supply for complete combustion to minimize the production of incomplete combustion products.
Co-liquefaction can be divided into two, which are direct co-liquefaction and indirect co-liquefaction. Indirect co-liquefaction, coal is directly converted into liquid fuel through a chemical process. The process involves heating coal in the presence of a solvent and hydrogen gas at high temperature and pressure. In indirect co-liquefaction, coal is first gasified to produce synthetic gas, syngas, which is a mixture of carbon monoxide and hydrogen gas. This gasification process involves reacting coal with steam or oxygen at high temperature to produce syngas. Generally, the main product of co-liquefaction are liquid fuel such as diesel, gasoline, and jet fuel. Additionally, co-liquefaction can also produce byproducts such as tar, coal, and various chemicals that can be used in other industries. Generally, co-liquefaction process have an energy efficiency ranging from 15% to 70%. This means that for every 100 kJ of energy contained in the coal feedstock, approximately 15 to 70 kJ of energy can be obtained from the resulting liquid fuel and byproduct. The pros of co-liquefaction are cleaner liquid fuel, efficient energy utilization, potential for carbon capture, and utilization of existing infrastructure. For cons are co-liquefaction can result in carbon emission, water consumption, waste generation, and technological challenges and costs.
Next, I will explain about the pros and cons of co-gasification of processes in terms of producing clean energy. Co-gasification is the process of converting coal into a gaseous state that may later be a fuel. Co-gasification is widely regarded as one of the most practical and cost-effective clean coal technologies for the manufacture of synthetic fuels, chemicals, different thermal utilizations, and power generation. It provides a realistic method of using coal in order to fulfill demanding environmental standards. Recent interest in co-gasification has been to produce clean energy power. Co-gasification process improves energy efficiency in clean coal technology. Hence, it is predicted to be employed more widely in power generation and chemical raw material manufacture. Firstly, the pros for co-gasification is the production of synthesis gas. Co-gasification allows for the production of synthesis gas, syngas, which is a versatile fuel. Syngas can be further processed to produce valuable chemicals and fuels, which includes a variety of products such as hydrogen, methanol, ammonia, synthetic natural gas, and liquid fuels. Moreover, it can be used as a substitute for natural gas, which makes it suitable for heating, cooking, and electricity generation. Next, co-gasification allows for more efficient control of air pollutants such as sulfur dioxide, nitrogen oxide, and particulate matter, which results in reduced air emissions. The third advantage of co-gasification in terms of producing clean energy is the potential for carbon capture and storage. Co-gasification provides an opportunity for carbon capture and storage, wherein carbon dioxide emissions can be captured and stored underground, preventing them from being released into the atmosphere. This can help mitigate greenhouse gas emissions and combat climate change. Co-gasification does not eliminate environmental concerns associated with coal. This process still generates greenhouse gas emissions, including carbon dioxide and other pollutants, in which these emissions contribute to air pollution, climate change, and negative health effects. The second disadvantage of co-gasification is waste management. Co-gasification produces solid waste in form of slag or ash, which requires proper disposal. Depending on the composition and toxicity of the waste, it may pose challenges in terms of storage, treatment, and utilization. Moreover, co-gasification is a complex process. Maintaining the reliability and efficiency of gasification plants can be challenging, and unexpected operational issues may arise. Lastly, co-gasification requires large amount of water for gasification processes and cooling purposes, which may lead to water scarcity. Not only that, the wastewater generated from co-gasification can contain various pollutants such as heavy metals and chemicals, posing risks to water quality and lead to contamination of water if not managed and treated adequately.
Combustion technologies such as fixed bed combustion and fluidized bed combustion typically have lower overall efficiency compared to coal liquefaction and coal gasification. This is primarily due to the inherent inefficiency associated with the conversion of heat energy into electricity or other usable forms of energy. Coal combustion technologies such as pulverized coal combustion in power plant typically have efficiency ranging from 35 to 45, which is lower than 50%. This means that only about 35 to 45% of the energy contained in coal is converted into usable energy in the form of electricity or heat. In contrast, coal liquefaction and coal gasification can achieve higher overall efficiency. Their process can have efficiency in the range of 40 to 60%, which is more than 50%, as they convert coal into fuels. This is because coal gasification allows to produce syngas. The syngas can be utilized in combined cycle power plants where the waste heat from the gas turbine is used to generate steam and drive a steam turbine, thereby improving the overall efficiency of the system. The syngas also can be used directly as a fuel for power generation or further processed to produce chemical, liquid fuels or hydrogens. The higher efficiency of coal gasification are attributed to the ability to capture and utilize a larger portion of the energy content of coal. Overall, coal liquefaction and coal gasification tend to offer higher efficiency compared to conventional coal combustion technologies.
The primary resource utilized in coal combustion is the coal itself, which is a fossil fuel abundantly available in many regions of the world. Coal combustion utilizes coal directly as a fuel source, which is requiring minimal processing before it can be burned. This allows for the efficient utilization of coal reserve and the optimization of energy production from this resource. Coal is the main resource used in the coal liquefaction and it is used as a conversion processor's feedstock. This makes it possible to convert coal, a solid fuel, to a fluid fuel that may be more conveniently stored, shipped, and used for a variety of purposes, such as transportation. In order to convert coal complicated organic structure into more straightforward hydrocarbon molecule, it is necessary to expose it into an extremely high temperature, pressure, and also the addition of hydrocarbon or catalyst. Coal is the main resource used in the coal gasification and is the feedstock of the creation of syngas. Syngas can be utilized as a source of energy or as a raw material for the synthesis of fuel such as natural gas, hydrogen, and synthetic hydrocarbon, as well as chemical fertilizer and fuel-grade material. Make it possible to transform coal into a versatile, cleaner burning gas that can be used in a variety of businesses. This procedure makes use of the plenty coal supply, enabling its transformation into numerous forms that can be used in the creation of different chemical and fuel. Creation of different chemical and fuel, power generation, and also transportation. This procedure aids in the optimizing the natural resource worth of coal by extending the variety of uses and improving coal utilization efficiency. Coal combustion for the electricity generation has a significant adverse environmental impact. It releases air pollution and greenhouse gases, leading to fog, acid rain, and also compromised air quality which harm human health. Moreover, the combustion of coal contributes significantly to carbon dioxide (CO2) emission, exacerbating climate change and its consequences. The release of substantial amount of CO2 into the atmosphere during coal burning accelerates global warming. The mining of coal, which provide the fuel for combustion, can seriously degrade the environment. Common effects of coal mining include logging, soil erosion, and ecosystem change. Additionally, the extraction process may result in the wildlife and local residents being uprooted as well as habitat loss. Coal liquefaction offers certain advantages, but it also carries negative environmental impact. Carbon emission resulting from coal liquefaction operation can be contribute to the climate change. The high water and energy requirement of the process can strain local water supplies and also increases greenhouse gas emission if fossil fuels are used for the energy production. Proper management and treatment are necessary in order to address these challenges. Coal gasification generates air pollution, including sulfur compound, nitrogen oxide, and also fine particles, despite reducing some compared to the conventional coal combustion. Effective air pollution management is necessary in order to mitigate their environmental and health impact. Water usage in coal gasification can strain local water supplies, and also the land requirement can disrupt habitat. Coal mining for gasification can also lead to the land degradation. These are considerable environmental effects from the coal combustion, coal liquefaction and also coal gasification. These include ash disposal, water contamination, pollution in the air, greenhouse gas emission and also land degradation. The environmental effect of these coal-related processes must be minimized in order to make the switch to the cleaner and more sustainable energy sources.
Carbon capture and storage, also known as carbon capture, utilization and storage, CCUS, is the process of retaining carbon dioxide emissions and utilizing them to manufacture things or storing them permanently underground. In coal combustion, inherent carbon dioxide capture allows for the lowest theoretical efficiency penalty while also producing a stream of pure carbon dioxide and water which can be easily stored underground or fed into the carbon dioxide conversion process. In coal liquefaction, carbon dioxide processed by coal liquefaction could be a key technology to reduce total cost of carbon capture and storage in carbon dioxide shipping. Optimal design and temperature should be determined considering both the capture process and liquefaction process, because gaseous carbon dioxide should be liquefied to be carried by ship and it needs more power consumption at lower temperature. Coal gasification provides some of the least costly methods for large-scale carbon dioxide capture for sequestration in deep geologic formations away from the atmosphere. However, the carbon dioxide is likely to interact with other products, hence complicating potential environmental impacts. The fifth factor is co-products and byproducts. Depending on the exact process and nature of the materials involved, the possible use or disposal of the co-products and byproducts created in coal combustion, coal liquefaction, and coal gasification might vary. Some examples of the co-products and byproducts from the three processes are liquid fuels, synthesis gas, and solid residues. Some of the products of coal combustion includes carbon dioxide, water vapor, particulate matter, gaseous pollutants, sulfur dioxide, nitrogen oxide, bottom ash, fly ash, and boiler slag. Bottom ash is used in road base and construction and used as a raw material in the production of lightweight aggregates, while boiler slag is used in roofing granules and blasting grade, and fly ash is used in the manufacture of cement, concrete, and building materials. Products of coal liquefaction includes liquid fuels, coke, sulfur compounds, tar, and pitch. Liquid fuels and coke are used as fuel source. The product of coal gasification is synthesis gas, which is used to make a variety of compounds including ammonia, methanol, synthetic natural gas, and other hydrocarbon fuels.
The next factor to be considered is scalability and commercial viability. Two figures shown are the instruments set out for fixed bed combustion and fluidized bed combustion. The setup for both technology can be said similar. Fixed bed combustion technology typically involve lower capital costs compared to more complex technology like coal liquefaction and coal gasification. This is because the equipment and infrastructure requirements for fixed bed combustion technology are generally simpler and less expensive. As for application, fixed bed combustion, particularly for smaller scale applications such as residential heating, industrial boiler, and small power plant, while fluidized bed combustion has found widespread use in larger scale power generation plants and industrial application. Coal liquefaction can be used as transportation fuel or feedstock for the petrochemical industry. The market potential for coal gasification is promising, especially in regions with abundant coal reserve and a desire to reduce carbon emission. For example, China used to convert coal into synthetic natural gas, chemicals, and liquid fuel. The last factor is technology maturity and development. Fixed bed combustion and fluidized bed combustion have advanced control systems to optimize combustion efficiency, the integration of gasification technology to convert solid fuel into a gaseous fuel before combustion, and the development of new materials for the combustion chamber to improve durability and reduce maintenance costs. Also, there is ongoing research to improve the economics of coal liquefaction by reducing production costs and increasing product yields. In addition, there is ongoing research to improve the economics of coal gasification by reducing production costs and increasing product yields, as well as exploring new applications for syngas in the production of chemicals, fuels, and other products. For application, fixed-bed combustion technology is suitable for small-scale application and certain industrial process, while furnace-bed combustion technology is employed in larger-scale power generation and waste-to-energy facilities. For example, the production of electricity from coal-fired power plants, production of heat for industrial process such as cement production and steel manufacturing. On the other hand, coal gasification technology focuses on converting coal into syngas, which can be used for power generation, chemical production, and as a precursor for other products. Coal liquefaction technology, on the other hand, aims to convert coal into liquid hydrocarbon fuel similar to petroleum-based fuel, primarily for transportation and heating purpose.
Comparing different methods of coal utilization, we find that fixed-bed coal combustion allows for the direct use of coal as a fuel, but it has a lower efficiency and generates solid waste ash. Fluidized bed coal combustion do offer improved efficiency and emission control. It still produces solid waste ash. Coal liquefaction converts coal into liquid fuel for storage and transportation, but it has a carbon emission, water and energy requirement, and also it has a waste management concern. Coal gasification produces a versatile syngas and allows for the carbon capture, but it generates air pollution and waste stream. Factors like coal quality, infrastructure, and regulation influence the choice of method. Thus, it is crucial to explore cleaner and sustainable energy as an alternative in order to minimize the environmental impact of coal utilization.